Learning about food can be exciting and fun. The science that goes into a batch of homemade cookies or that sweet tea you order at your favorite restaurant can be complex. Nonetheless, it's exciting to learn about the processes that are involved in those foods and how our bodies react to it. Starting off with one of my personal favorites, cookies and cakes. Although these delectable desserts share many of the same core ingredients, they are structurally different. Why is that? Well, this is because of the fat that is used to make the dessert. In making cookies, you often see some sort of solid butter being used. Because butter is saturated fat, meaning it is a straight and long chain of carbon and has its bonds saturated with hydrogen, it can form bonds pretty easily and stay solid at room temperature. When reaching its melting point, then does it spread downwards. This explains why at room temperature, dough remains pretty solid and malleable compared to the batter of cake. Cake, on the other hand, often uses some sort of oil as its fat. Oils are not solid at room temperature, rather they are liquids. This is due to it being an unsaturated fatty acid, meaning it contains double bonds that do not allow hydrogen bonds to fully bond with carbon. When this occurs in the molecule, a kink in the chain forms that disrupts the bonding with other fatty acids, weakening its structural integrity and making it more fluid. When added to cake batter, the batter appears to be more fluid. The use of either butter or oil as a fat in cookies and cakes also affects its moisture content and the shelf life. Cookies have a relatively low water content, around 6%, but it varies depending on the type of cookie. If you want a softer, chewier cookie, you would most likely bake it for a shorter amount of time. This means that the cookie will have more water that results in a softer cookie, allowing for higher moisture content and vice versa for a hard cookie. When you consider the moisture content of cakes, they have an intermediate water content, around 25 to 30%. This is because of the contribution of moisture from oil as well as the ratio of flour to liquid, more flour resulting in a lower moisture content. Baking time and temperature also reflect differences in moisture content. If you really want to decrease the cake's moisture content, you can increase the amount of soluble material in your cake, such as sugar or salt, as their properties lock up water and batter. Salt will be more effective as it absorbs 10 times the amount of water than sugar. One notable reaction that occurs in cake making is the Maillard reaction. This occurs when the proteins and sugars break down when enough heat is applied, and as a result, they form new compounds. Some noticeable features that make a dish unique, such as color, flavor, and aroma, occur thanks to Maillard reaction. When you bake a cake, the browning that occurs when the cake reaches 280 degrees Fahrenheit is the Maillard reaction in action. Another great example of the Maillard reaction can be visibly seen in the browning of French fries when they are cooked in oil. Caramelization is a separate scientific concept that is similar to the Maillard reaction but should not be confused with each other. Simply put, caramelization occurs as a non-enzymatic process. It is the browning of only sugars. This occurs due to introduction of heat and the removal of water to become glucose and fructose. Caramelization is also one of the last steps in making a cookie. Almost all cakes will be sweetened with sugar, but did you know that there are other varieties of sweetener out there? Each variety of sweetener has a chemical difference. Starting off with the most recognizable, table sugar, which is simply a disaccharide of glucose and fructose. High fructose corn syrup also involves glucose and fructose, but they are not bonded together as they are in table sugar. Different versions of high fructose corn syrup can be due to differing ratios of glucose and fructose. Honey also involves glucose and fructose, but what makes it desirable is that it's found in nature and contains 181 different components that give it a distinct flavor profile. Finally, artificial sweeteners are a great substitute for sugar when you're looking for something sweet but with no caloric value. This is because the body does not know how to process some of the artificial sweeteners and ingredients, such as aspartame found in E. coli, depending on the sweetener you use.